Okay, Wanda is taking a water sample from the Glover River and putting it in the jar. Wanda, let me see your water sample. Okay. This is from the Glover River.
We measure the depth of our in 5 different places across our little creek here, and we also recorded a second time the depth nearest us in the middle and the far end, and we would average those 3 numbers, and so we'd have an average depth. And as far as measurement, if you use feet and inches in your class, use feet and inches. If you are teaching the metric system, use the metric system. And so we'd have an average depth. Our stream width, this is 14 feet across.
That is a homemade
velocity flow meter.
Homemade flow meter.
Okay, so that is at 90 degrees, holding the protractor level with the surface of the water.
Water temperature with that, and then this is pH.
Okay.
So we just need to turn it on and just hold it in the water for a little bit.
We want it on Celsius?
Sure.
Okay.
I would put it on, like whatever grade level you teach. If it has anything temperature in it, if Fahrenheit is what you do,
Fahrenheit
that's what I would.
is what we do.
And then I would rate.
And Celsius, we have to do both.
Fahrenheit, yes.
Okay. So do we just go in the middle, or?
So show me the devices. One is for.
This is to measure temperature.
Yeah.
Air temperature and water temperature.
Okay.
This is to measure the pH balance of the water.
This device is actually a gardener's tool to measure soil pH, soil moisture, and the amount of light that your houseplant is getting. And so we were using that here. It's a little sturdier, so you can actually poke it in the ground.
It looks like. Okay.
But right there's the little light detector, and so it's. The directions will tell you to take one of these dissolved oxygen number 1. So we're going to take the lid off. Now you can take the lid off. And we're going to dump this in there.
Put the lid back on.
Put the lid back on. And then shake it. The directions will then tell you to take number 2. Oxide is what it is, and it's like hemoglobin in your bloodstream binds with oxygen. These chemicals bind with the oxygen in water, and it'll settle out. Once it settles below this white line, you're to. Procedures say to invert it 15 times, and the procedures are written so that everybody is pretty well doing the same thing, regardless of whether you're in Belgium or Japan or Thailand or.
Leave it on.
And then we let it settle again. Now we might want to one time, but the little kit has these little vials in it. It's much like what you do for a swimming pool. The nitrogen, ammonia is like Windex ammonia. It's nitrogen. The nitrogen can come from wheat. Farmers putting nitrogen on their fields. Could come from most anywhere. But we're going to take some of the water that we collected out of the creek and just fill up this vial. Now there's actually rinse procedures, like put some in, slosh around, dump it out. Do that 3 times. And that's good. Oh, a little up to the top of the green.
What are you testing for here?
This is nitrogen.
Nitrogen.
Testing for nitrogen. And ammonia.
And we're going to dump this in.
Say that again.
Ammonia, nitrogen. You ready?
What are we adding now?
This. Yeah, you thoroughly saturate it.
Got that? Ammonium.
Cyanide. You do them at the same
Cyan.
Cyanurate. Cyanurate.
Cyanurate. Cyanurate.
at the same time? Or?
And then we shake it all up.
Well, it says 2 testers. As long as you saturate.
There we
We're
go.
going back. We're not even to the 15-minute part yet.
Now this actually takes 15 minutes for the color to develop. But what you do is you match this color, which had your water in it, to these prepared, in whichever one, and they're labeled.
For 3 minutes.
These are labeled 0, 0.2, 0.4, 0.6, 0.8, and 1 milligram per liter, 1 part per million of ammonia.
Ammonia.
So the greener it is,
The more concentrated it is. And this is pretty yellow.
With your right side up.
so it's not very concentrated.
No.
Why'd you
See how yellow it is? It's not totally yellow, it's a little green. You could say 0.1. You can read
I
it.
see it on the camera.
And then just dip it in here and let it get saturated.
Pregnant.
This is you got your thumb holding it. So the way your thumb is holding it, this is your thumb right here. So then the pads are underneath it. So this one is nitrites, and this one is nitrates. And these turn pink, whereas the phosphates turn green. These are designed to turn pink. If the pinker it is, the more concentrated. So if you just hold that,
Oh, no, I was wondering if it was.
it is. And we're just going to dump that inside of here.
Acid.
That was fun. That was like a tornado reaction.
In a laboratory,
Oh,
you'd probably
my.
use sulfuric acid, but it dissolves up that precipitate we made. It's probably the same acid that's in rhubarb, oxalic acid.
I love rhubarb.
And rhubarb tastes, the ends are poisonous, but it has a bitter taste to rhubarb unless you make rhubarb pie. But it all dissolved up.
Oh.
We're going to put starch
Where's our blanket?
in here. 2 drops. And it should turn, the yellow is iodine,
Wow,
and so it should turn a blue color. Or
that's fun.
stir it all up so it's this kind of bluish color. Chemical that film developers use, and it's chemically a sodium thiosulfate, but we're going to add this to the bottle drop-wise, 1 drop at a time, until it turns colorless. There's 1 drop. If you're that high, it's going to be maximum oxygen concentration.
You say you could only do